Hi and welcome to another MoTeC webinar. My name's Pete Swinney and today we are part 2 of the introduction to M1 diesel tuning. So today's topic's just going to cover off the different hardware versions that we offer for the diesel solutions and the different packages and some of the key channel names and what they mean in the diesel packages as well, and there's some different worksheet layouts and tune. Alright, starting off with hardware. Effectively, well, there's three kind of types. We have a high current solution, that's the M142 series, where the maximum hold current is 15 amps and the maximum peak voltage is 80. And then we have the M141 version where the hardware is specifically targeting piezo injectors, so a lot higher voltage drivers and so forth on board, but only a hold current of 10 amps. And then lastly, in the rare case of some diesels have injector drive boxes on board, and the Toyota Hilux 1KD is an example of that. So in that case, our existing port hardware can be used. So that's like the M150 and M130. So that's only suitable for vehicles with injector drive boxes on board, and still needs to run a diesel package to control the fuel pump and in some cases the excess pressure valve. Alright, so that's hardware. And packages wise, at the moment of doing the webinar today in early 2018, we're offering a GPR diesel, which, as the name suggests, is pretty much the same as our current GPR petrol packages. It also includes exhaust gas recirculation control, the launch and traction, which is the GPR side of it, closed loop fuel, which is quite unusual in a diesel, and not actually that commonly used. So we've done it's a different version of that for the diesel, and compound turbo control is also just being finished off as well. So that's for running two turbochargers sequentially into each other with bypass valves and so forth. Quite a bit to manage when you're doing that. Then we have a second package, which is more of a commercial package, and that's called GPR Diesel Dual Fuel, and that's for use with customers that are targeting using a second alternate fuel, like CNG and LNG. So that's where generally these customers take a standard diesel engine and then put on a second set of injectors and run that alternate fuel into it. It's more for a cost reduction exercise for commercial fleets, and so we've got a lot of extra features in that package to manage the detonation and manage the second fuel to come in and to be able to come in and out of substitution without affecting the power. It's quite difficult to achieve, but anyway, that's what that package is all about. So a nice solution for those clients, and everything working just as they would expect. Alright, so some different channels to explain to you, something you haven't seen in the petrol versions. The first one's lambda estimate. Now, this channel kind of exists in the background of the petrol packages, and that is it's actually the channel that what the ECU thinks the lambda calculates out to be based on what it's currently measuring the airflow and fuel flow as. So if the injector calibrations are accurate, then the ECU should know exactly what fuel is going into the engine. And if a petrol engine was using an airflow meter, then the lambda that's measured and the calculated lambda would be exactly the same. Now, in a petrol package, what we do is the tuning process is if we ask for a certain lambda, we go for a certain target fuel mixture aim. Let's say that's lambda 0.90, and if that lambda isn't correct, we can push our Q key to quick lambda the efficiency map, and what that's actually doing is simply correcting the ECU's calculation of how much air is going into the engine. So the ECU is looking at the fuel that's being used and the current airflow calculation via the efficiency map, and so if the lambda is not on aim, that means the airflow calculation is incorrect. On a petrol package, the airflow calculation is based on an efficiency map that you tune. Once you press Q and get the lambda actual to meet the lambda real, then the efficiency map is therefore tuned correctly. The ECU knows how much air is coming in, it knows how much fuel is coming in. So in the background, the ECU's lambda estimate actually is the same as the real lambda as measured. Now in a diesel, sadly, it's not that easy. So it's we have a double lose, if you like. In a diesel, we have injector calibrations that are very difficult to get accurate, and we'll talk about why that is in a future webinar. So difficult to get injector calibrations accurate, and it's also quite difficult to get the airflow calculation accurate using an efficiency map, and that's because the variable nozzle turbos greatly affect the engine's efficiency, as does engine speed, as does the fuel mass, and there's so many different things that can affect the engine efficiency. It's not simply practical to use that as the best means of calculating airflow into the engine. So we use and recommend that you use an airflow meter to calculate the airflow going in. Now, in the absence of an airflow meter, the ECU is reverting back to the engine efficiency table, but all along during this process we have what the ECU thinks the lambda is. And so if there's a big error between what the ECU thinks the lambda is and what the actual lambda is, what that tells you as a tuner is that one of your calculations is wrong. Either the fuel calculation is wrong or the airflow calculation is wrong, and in an ideal world we would get the actual lambda to meet the estimated lambda, and so what that tells you when you get that to happen is that the current method of calculating the fuel coming in, i.e. injector calibrations, and the current method, whether that be efficiency table or airflow meter based, is also accurate. So that lambda estimate channel we're looking at that all the time, and a lot of tables actually use that as a means of controlling, for example, smoke and things like that. So lambda estimate, new channel, so we're going to be keeping a sharp eye on that, and it's an integral part of tuning and getting things right. Alright, next one is the engine charge and the engine charge estimate. So in diesel, when we're talking about tuning a diesel, we refer to everything as a weight in milligrams. So our fueling, we define a particular amount of fuel that we want to be delivered, an actual weight, so in milligrams. So all through our tables, and the vast majority of tables, we're asking for certain milligrams of fuel. So whether it's 50 milligrams or 100 milligrams or 120 milligrams. Now, if you have good injector calibrations, then a typical 3-liter diesel is going to be using 100 milligrams of fuel at around standard power, whether that's something like 350, 400 newton meters, 500 newton meters. I'm sure there's a more accurate estimation of that, but that's the kind of number that we see, around 100, 110, 120 if everything's calibrated up correctly. So we have idle amounts defined as milligrams, pilot amounts of fuel defined as milligrams. So the fuel definition generally throughout the program or throughout the package is defined as a milligram amount. Now we do the same thing when it comes to air. So it's not about the flow of air. We determine the engine charge. Each cycle is calculated and becomes a specific weight of air per cycle. And so that's a specific weight in milligrams of air. And the lambda estimate that we just talked about simply divides the milligrams of air into the milligrams of fuel, and you get an air to fuel ratio, which is then converted to lambda. So you can do the maths on that if you want to look at some of your logging if you've done some of this previously. So that's how lambda estimate is created. It is by measuring or calculating how much air is going into each cycle and how much fuel is going into each cycle, and then creating an air-fuel ratio based on that. Now, engine charge is the channel that expresses that weight, and that is a channel that is only active when we have an airflow meter active with an air temp correction. So if we have the airflow meter configured and working and within range, then it'll give you the direct engine charge, which should be accurate as long as the airflow meter calibration is accurate. And we'll talk more about airflow meters in a later webinar. The engine charge estimate table is the channel that the engine charge refers back to or diverts to when the airflow meter or air temp sensor drops out. So the engine charge estimate channel is derived from the efficiency map and air temperature. So if we have no airflow meter either configured or the airflow meter is out of range because you're flowing more than what it can handle, then the next method for calculating the volume or the weight of the air going into the cylinder on each cycle, the ECU uses the efficiency map to do that. Now, as I said earlier, the efficiency map is quite difficult to tune accurately. It's quite easy to tune broadly. If you entered a number of 90 everywhere, that would be a good starting point. But to get it quite accurate, which is what you want to do if you're going to finally control smoke, then it's difficult to get that to happen using just the efficiency map with all the different things that affect the engine efficiency on a diesel engine. So the preferred method of determining the airflow through the engine is to use an airflow meter, air mass meter. All right. So final slide for this webinar, worksheet layouts. Now it's not a major change here, but what we have done is to split up our tuning workshop, tuning worksheets. In the GP packages, there's one workbook full of tuning worksheets, and what we've done in this particular case is we've split that up into two lots of tuning worksheets. So to kind of show you the tables that are most commonly tuned without too many parameters involved and looking confusing, we've split up the common tables and the common things that you would use if the engine came to you running or you had a start file from us. And this first set of tuning worksheets would be what you would spend most of your time in. Then the second set of tuning worksheets, there's lots of extra setup and lots of parameters to do with the pilots and post injection and fuel pressure and stuff like that. So to try and make the whole process a little less overwhelming, we've split those two lots or that one lot of worksheets into two workbooks. Alright, and that's the only major difference in the layout. So what you can do to help flip between one and the other is to set up the quick keys or the shortcut keys, and hopefully you know how to do that if you've been using your M1 tune for a while. But the short explanation of that is to unlock the package, go to the layout and the key bindings, and then you can set up F7 is kind of similar shortcut key that was in the gold boxes. So I use F7 to flick between the tuning boost control and the tuning setup boost control. And so that way you can flip from one row of worksheets to the other quite quickly. And yeah, just an easier way of getting around. All right, so that's it for today, and hopefully that's been given you some information. And thanks for listening, and we'll catch you next time.